Okay. It's a great pleasure to be here and to give some introduction of our work and ideas. Well, thanks for the workshop because it's not much like the IETF work style, and we can propose some maybe radical ideas and to receive some comments, and we can move forward. First of all, I think I can, because I'm fresh new here, so I will introduce myself and my lab. I'm from BII, Beijing Institute of Internet Institute, and now we have a lab to set up the simulation of the route system, and I want to demonstrate to other people how it works, and helping to correct some misunderstanding of the impression of people maybe in China or in other area of the world. And now we are also do some tests and verification, verify to the latest proposals happen at the morning. There are two proposals. We implement some of them and to give some test results. And we also want to find new possibilities or something interesting in research area. So that our motivation to present our work. The title we modified a little bit compared to the 0.0 version. We used the modifying the use of TCP instead of use the TCP by default in the prime exchange. Some people may already read my draft in the working group. So okay, I will mainly focus on two parts. The one part is the some technical experiment and recommendations, some from the some observations for the interesting research directions, and the second part is we come back to the draft and the motivation why we use TCP. The first part is the prime exchange. The second part why we use TCP. Okay. I think most of you are very familiar with this part. I just mentioned it as a background. The prime exchange is act as a bootstrap process and to help the recursive server to find the least. We'll check that. Okay, to get the current list of the root name server, it also called the S4 dot query, and okay. So I initially write down a draft describing my concern on the current situation, the priming in the dual stack scenario, because there's a description in the SEC 018 that in their special sequencing that the quarter A records may be well not fully fit in the limited packet. So I mentioned, I propose that there is some risk that if there is not enough the glue for the IPv6 root server, so it may be some risk in the resilience of the root system. After the I drafted make this draft, and then I do some reading to that very question, and they mentioned that there are some performance problems may happen if their additional section is not complete. So I have the question in mind: what the prime exchange triggered, and what happens if the v6 glue is unreachable, and how bad it is. Before I gave this presentation yesterday, I just made a test and to show to address the question in my mind. I just sent a query when the resolver start up, and I found that it is the prime exchange only triggered by the missing of the cache, of course. So it's not the case for my the first impression, first understanding of when the resolver just start up, it issue the priming exchange. So the first step is the query, then the priming exchange. But I also found that there is a different, how to say, different sequence that the reserver also send quarter A query direct to the a router, key router in my case, in my test, at least in the hint file for the result. So I found the step 2 and step 3 done at the same time in the aperture way. So I don't know is the current it's the version or the different the DNS software determined in this way to get rid of the latency. For that, so I need more tests on that part. Okay, so there is also a different concept on the priming exchange, the truncation on the priming exchange related to the very case of my study. It's a hard truncation and soft truncation. We call it hard truncation just for the answer section that is not complete, not fit in the response. We said TC1. And the soft truncation is that if the referral response is not contain all the information, it will set TC1. It's not down in the current system, but if we pay attention to the prime exchange, the information in the A and quarter A asset is very important for the reserver, according to the protocol definition. So I done another test, and there, what we want to do is to find the points which triggers the soft truncation and the hard truncation. We constructed an artificial root zone having range of root servers with different population from 1 to 100. Use a different label, 1 to the 0 to the 99. Each one have a unique A and a quarter A, and we sign them, and we perform in the dig prime query against each zoom, and want to find the point triggers the soft truncation and hard truncation, and we tried different size limitation, the 3 different size, and we found that in the soft truncation case, we found that in the 512 byte there are always a soft truncation. If there is only the prime exchange, if the reserver only rely on the prime exchange and the additional data of the A and quarter A, it may be cause the delay to issue another A and quarter A to the name and server. If there is bigger the size of the response, it may contain more NS server and the quarter A and A the address, and it's much it's good for the hard truncation because it only needs enough the NS record in the answer section. So there may be some recommendation we can discuss that the route DNS implementers should be aware of the possibility of soft truncation and should treat the absence of either an A or quarter A for any root name server as evidence in favor of soft truncation in that case. Okay, that's the that work we done to demonstrate the observation. We focus on the prime exchange for the current system. There's another 2 possible directions. One is the DNSSEC for priming. We all noticed that the DNSSEC does not sign glue, and because the delegation makes it happen, this way. But if the reserver, I think there's some discussion that the reserver validates both the NS the sets as well as the A and quarter A asset. So how about if we move the server name out of the root servers.net just to the root zone? So there is no dependence on a specific root server to sign the data. We can provide a better way, more efficient and secure way for the prime exchange. That's the possible direction or ideas I come up with. There's another possible direction is that I heard a lot of discussions and concerns about DNS record for the root zone. Yeah, it's all contained in the prime exchange. Also, the size of prime exchange limited the number, but I don't want to go more detail and more controversial topic on that part. I just wonder if there are more, give the assumption that if there are more certain DNS records, is there any technical factor we should be considered, we should be concerned in advance? So that's some open questions that with more DNS record, how to guarantee the performance of the DNS selection process, because there may be 100 or 1,000 DNS records in serial. So another question is how to distribute the room data in such a scanning model in a timely manner. I think that's the transfer, that question is also should be answered by the BII proposal and the Kumara's proposal, because there's need more replication of the root data. And also maybe there are some interesting research topic about how we determine the optimal or reasonable number of DNS records. Maybe we will build a model to simulate the current topology of the internet and find some limitation or latency of the DNS topology. Okay, that's two possible direction or radical way to think about how the prime exchange may be changed a little bit. Then I will go to another topic related to the prime exchange that modify the use of TCP to support any changes we come out to the prime exchange. In RFC 1035, that the UDP the diagrams are preferred for the query due to their no overhead and better performance. But the TCP is required for reliable transfer, like the Zoom refresh activities, like Zoom transfer. So in my previous version of my draft, it is argued that the prime exchange is so important as a bootstrap process that it needs a reliable transfer. It can, in my previous one, I suggested using the TCP by default, but I think I can expand the possibility to modify the user, because there's not only one way to use the TCP. We can find another way. For example, change the truncation mechanism, like we introduce soft truncation to TCP, or other radicals thought about how to simultaneously to use the UDP and TCP at the same time. Just use that network. We use happy eyeball the approach to treat the different problem. So why we choose the TCP to support the possibility of the prime exchange is that we want to avoid the technical issue. One is that the IP level fragment caused by large UDP, especially when the EDS0 require the large support large UDP, and the truncation, the hard truncation, the current system hold, and even the more larger size than the 1.5 key for single UDP packet. That's the technical issue we want to avoid in the transmission of the prime exchange. So again, why use the TCP? That we think that for long term, bigger protocol data unit will therefore facilitate more advanced, more future design for scale the root system in the day to come. if we can come up with new, maybe more data should be contained in the prime exchange for its boots up for the resolver, we can just use the TCP to give the compatibility. Yeah. Okay. The solution is simple, straightforward, but there's other work we should do ahead of us. That is evaluation of the cost to use different modification of TCP in the prime, and any optimization approach to the TCP, and other technical requirement for both resolver and the root server, because there's no cost-free measurement or proposals, and also should consider the adoption strategy. A good news for that is that the prime exchange is rare. So I just look around to do some study on the node from the L root, from the K root. The prime exchange is rare, but it's important. But it's so important, so that's why, that's the rationale I just proposed this idea to share with us to discuss the possibility to use the TCP with some modification. And I also look into the performance, and there is a statistics, and we also do with my team that the performance is degrade, of course, but it is in a controlled manner, or we call it predictable. So compared to the UDP, there is unpredictable IP level fragmentation and other unpredictable behavior of the servers. So maybe the TCP is more predictable, and we can use it in a controlled manner. And also we do that if we want to put more information to the prime exchange with large size of packets, they need more fragmentations, not only in the UDP, but also the TCP. We see there dramatic degree of the performance, of course, and we noticed that it happened especially for the large packet. I found the answer to this is that the current DNS implementation not optimized fully to support the case that large packets, not only in the UDP and TCP. Maybe that's the direction we can discuss later. Okay, the future work of my team, I think, is to try to test the different prime scenarios, because we want to modify the use of TCP. So we used always initial TCP by default. This is one. Second is always fall back to TCP as default. Second, the third is try use the UDP and TCP query at the same time to see its benefits and all the cost. So I also will do some survey and research into the TCP optimization for DNS software implementation. Okay, that's all. Thank you.
Yes. So maybe I'm just being a little bit of a nerd, but I'm really appreciating the fact that you kept saying research. Mm-hmm. I think that some of what you said sounds surprising, and therefore it's good to have research on that. Mm-hmm. I'm a little bit concerned that your research is done in the lab with, sample servers. I would hope that you could do research across the internet. Mm-hmm. Since a priming query, you can replicate a priming query, what would look like a priming query from this open resolver or resolvers that are around the world. Mm-hmm. I think that what you'll find will be very different than what's in the lab. I don't know how it will be different, of course. But I think that having research on this where you're doing, where you are replicating what everyone around the world would see in different scenarios would be actually very, very valuable. So I hope you continue on that with sort of an expanded scope. And then one other brief comment, you many slides back said you can tell if you had a soft fail if you did not get IPv6 addresses for everyone, except E doesn't give you ever an IPv6 address. e.rootservers.net doesn't have an IPv6 address. And therefore, you would have to special case that, and I think that's too much special casing to ask a server to do, something to do. So that piece wouldn't work. But still, I think you could find a lot by doing research across the net and working with other researchers. I mean, the nice thing is that the queries you're doing and such are fairly simple. And so if you have a problem doing it from a certain place, maybe ask some researchers in that place to be doing it for you and things like that. And Jeff, so I figured that this, I didn't know if this was something that you could do within your realm, but APNIC, yeah. So please at least talk to Jeff about that as well.
Let me ask that other questions be briefer.
Okay.
And we have a 30-minute slot here. Who's next? I saw a lot of hands up earlier.
Oh, Jeff has.
Jeff.
I just have a quick comment about this. We did some testing on basically how much of the internet will respond to TC=1 and revert to TCP and do the query. Tested 1 million clients. That came into 80,000 resolvers. 13,000 will not do TCP. So 17% of the resolvers, when given TC=1, kind of go, well, stuff you, I'm going to walk away from this. That's 6.4% of those million people. So there's a relatively large amount that just don't like TCP. It's not completely bad news because most users have 2 or more resolvers in there, etc., resolve.conf. And so 3.8% of those folk, of the 6.4, so a little over half, the second resolver did TCP. But of the ones that were stranded, 3%. So 3% of the world's clients, when you say to the DNS it's TCP only, sit there and go, I have no service. And for my mind, that's uncomfortably big. And maybe I'm just splitting hairs, but 3% of folk sitting behind resolvers that will not do TCP is an awfully big number.
But to
17% of resolvers won't do it, and 3% of folk, their entire resolver set, all the resolvers they've configured, none of them will do a TCP query.
right, although I think what Davies' research is on is specifically on priming.
Yes.
Yeah,
And so it's actually the number of recursors.
17% of the resolvers, the recursors,
Right.
if you say, go and do TCP priming, will sit there and go, don't know what you're doing.
They do not support the TCP.
They will
actually.
not do a
Yeah.
TCP request.
Yeah.
Andrew?
So I'm saying the resolvers that ask me an authoritative name server, I send back TC=1, and I expect it to come back at me with TCP.
Andrew, then Terry.
But if you just, I mean, if we just change, if we created a, so first of all, priming queries are not actually specified really anywhere, right? I mean, there's a draft that's been floating around for about 1 trillion years that hasn't that hasn't come through, and it's got some problems with it. If we just change the specification to say, do your priming queries over TCP, then presumably, eventually over time, the resolvers that can't do this would break, and they just wouldn't work anymore, and then they would die. I mean, one of the things that I no. This is an important thing, right? That if you have a resolver population that is kind of working. This is the flip side of what I was worrying about earlier. If you have a resolver population that is kind of working, then that's bad. But in this case, what we would say is, well, you just make it so that the priming query only happens over TCP, and at that point, those things crash and burn. They don't work anymore.
You say that like it's a good thing.
I do think it's a good thing.
So-
This is what I just heard is 6% of these things don't work. This is a tiny population of the resolvers.
17% of the resolvers don't work.
Right.
Those resolvers, those 17%, serve 6% of 2.3 billion users.
Well,
Right. So
someone is better at calculating really quickly in their head than me.
so
That's about 160 million people.
I understand it's a lot of people.
Yeah.
But the point is that those resolvers, so they're down in the tail.
Yes.
And what happens is, the difference between, oh, it's kind of working, and if I restart this thing and so on, then stuff comes back, and doesn't work at all is really dramatic on the internet, right? And so the sort of works
Excuse me.
is a really bad case, I think.
Yeah, excuse me, I want to say, when it doesn't work, that doesn't mean that they know it doesn't work. So I will tell you that a lot of these things where priming fails means that they just use their hints forever.
Right.
So we've got monitors hanging off of the old root name server addresses. Almost all of the ones that have been renumbered away from are still monitoring their traffic. Most are receiving at least dozens of queries per second, and
Yes.
some are receiving hundreds.
I'm aware of that.
So
But-
I don't think we can say that we can improve our situation by breaking these people further.
They're just as they're no more broken. They're not going to get any more broken than they already are. That's sort of my point. If they can't do TCP now, they're already hosed.
Yeah. Any question, Jeff? Did you want to follow up?
That was the only data I have. It really was meant to be a data answer rather than a judgment afterwards. But, yeah.
Okay, so the only point I heard that was kind of left in an uncertain state was this business of imputing soft truncation. If there are name servers that I have written, some of which you have run, which if whatever comes back in the priming query is the set of records that will be used. There are other name servers I've written that you have run that if it does not get an A and a quad A for every one of the NS records in the priming response, will go query for the missing ones. And they don't have good hold down characteristics, and so that leads to query storms. So what I want to say is that if we cannot reliably impute the soft truncation event where we did not get all of the A and quad A's for some reason other than they aren't there, then we really do have to have a standard that says just start with TCP so that you can be sure that soft truncation is not keeping you from seeing some of the A and quad A records. Because the impact of not doing this is that some root name server might have both v6 and v4, but you will only ever try the one that you got because it's not going to query for the missing one. This is not one of those cases where it will query for the missing one. Warren.
I'm sorry, I must have missed something. Why doesn't just setting TC in the response get you what you're looking for?
TC
And if
is
you
going to
don't-
be set if the answer or
Answer
authority
section.
section cannot be completed.
Yeah.
You don't set TC just because you can't fit things in the additional.
Yes.
So that's why we call it a soft truncation event, is that it's not all there, but you don't know it. So this may mean that I will have to backtrack what I've said publicly, which is that we should not just start with TCP. But in fact, Davey and his team have come up with an actual real problem here, which is you need a full answer. So just because you didn't get a TC doesn't mean you got a full answer in this case. So we may end up with a proposal that we just do your priming query over TCP full stop. Paul Hoffman.
So this is a placeholder for tomorrow. Another thought, I guess if we had some radical thoughts right before lunch, we can have at least one right after lunch, is for discussion about root server operation is why send additional?
Yeah.
And I think that, again,
Yeah.
some of that can come from some of the research you're doing and such, but I think that's a reasonable thing for us to discuss tomorrow, is the sending of additional, is it still useful? What do we get from it? What would happen if we all radically stopped, et cetera, et cetera. So not now, because that will be a long one, but let's hold that for tomorrow.
Okay, thank you. Warren, can you make a note on the agenda for that? All right, are there any more questions, or can we move on to Declan?
Additional, last comment. Okay, thank you for all the comment and suggestion. Because the first draft, I think I'm a little ambitious to contain all the all the problem and want to solve. Okay, use the TCP to solve all the problem. So for the next version, I will more concentrate and more problem specific and work on all other commands following. Thank you.
Thank you.